Okay. So this is the bit where I do the audio visual check, but I believe that I've started the stream, so that's good. I'm keeping YouTube open just to confirm that that is indeed the case. I'm starting a little bit early. Okay. And I do seem to be able to hear myself, so that. So this is the bit where I do the
And I can hear
audio visual
myself,
check, but I believe that I've
so that's
started the
also
stream, so that's
great.
good. I'm
Okay.
keeping
I
YouTube open
do
just to
hear
confirm that that
multiple,
is indeed the case.
voices,
Starting
though,
a little bit
so
early.
I need to figure out which
Okay.
tab to close.
And I do seem to be able to hear myself, so that. So this is the bit where I do the
And I can hear
audio visual
myself,
check, but I believe that I've
so that's
started the
also
stream, so that's
great.
good.
Still hearing myself a whole
I'm
lot.
keeping
So there's
tons of these streams still open. Sorry about that. We're going to start in just a bit, but the stream has just started. Yay! One more minute, and then we're really gonna go for it. But I am happy to see that the stream is at least working. That's always a scary thing. Always got to double check that. Great. So if you're just tuning in, I always think it's fun to sort of see where people are tuning in from, because more and more people are tuning in from more and more further away and abroad. That's always kind of fun and cool. But the main thing that we will be talking today about is this new thing called HTML. Well, it's not really a new thing, but HTML has been around for a while. But the whole point is that we are going to be looking at a new way to do HTML. So let me just grab the site real quick, move that down below over here, and there we go. Fast HTML. This is what we're going to be talking about. This is the main site for a thing called FastHTML. It is a Python project. And the whole point of this Python project is that it should be kind of a path to do pretty elaborate web applications using only Python. Under the hood, there may be JavaScript running on your behalf, as well as a little bit of CSS. But the experience for you as a user should really be that you're really just focusing on being able to script with Python. And kind of the dream here is that maybe you don't need to be teaching yourself all these web technologies. Maybe if you can script a bit in Python, you can already do a bunch of more fun in web land. That's kind of where this comes from. So in order to sort of demonstrate the extent of what you might be able to do with this, I actually prepared a few demos. But I figured before diving into that, I might do the good thing and also just explain a little bit of the tech that is under the hood. So I'm going to explain some of the technology that FastHTML relies on before taking extra steps. One thing that is interesting to know here is that this project was started by Jeremy Howard. You might have heard from him before. He does a whole bunch of good work, FastAI, like a lot of these courses. That's stuff that he's well known for. But I did think it was pretty interesting to see someone from a little bit more of the deep learning realm have the need to really, like if you want to do stuff with LLMs, you also want to have like a UI for it. And my impression is that he and a bunch of his colleagues were just so frustrated with learning all this web technology that they ended up making their own framework. And you can hang out. They have a Discord channel. You can kind of hang out there. I also noticed some people from the Django community hanging out there. So even though it is pretty early, it is also interesting and cool to see that there is also some force behind it. But anyway, that is a very sort of brief introduction. What I figured I might do first is just explain a somewhat more modern and old school way to build web apps. And I kind of want to dive on that thing first. So normally, like these days, something that's been happening the last couple of years, if you want to build a web app, you typically deal with a front end and you deal with a back end. And excuse my handwriting, but what I'm also going to do is just redraw this because my face is in the way. Sorry about that. So as I said, there's a notion of a front end, and there's a notion of a back end. And the front end, the stuff you got to think about, that's usually like your HTML. That's stuff you typically put in there, right? And that's the thing the user sees, and that's the thing the user interacts with. So you can log in, you can do all sorts of fancy things, but every time that something needs to happen, the front end will typically communicate with the back end, and then the backend will send information back such that the front end can update. And very typically, like historically, we've not always done it this way, but recently, I think the last 10 years, the most popular way to do this is to have the backend return some sort of JSON that the front end can then pick up and can then do all sorts of logic with JavaScript to update the front end. And part of the reasoning here is that if you return JSON, that could be useful if your service also has an iPhone app, because then, the iPhone can take the same data structure and there's only one backend API that's necessary. And this approach has merit to it. But one sort of downside here is that if you are a Python person, suddenly you got to learn JavaScript if you just want to build a somewhat simple web app. So one sort of counter technology that's been gaining traction over the last 2 years is to say, well, let's rely less on JavaScript by just not returning JSON here and by just returning HTML here instead. So we're not going to send a data structure over that JavaScript then has to mangle. We're just going to say, hey, browser, here's the HTML, put it in the front end. And basically all the compute and all the heavy stuff, they're just going to be handled by the back end over here. This is basically what HTMX does. HTMX is a tool that makes this sort of way of working a lot easier. But it kind of does two things. Like one, it does assume that you're going to send HTML back, so it gives you a bit of the freedom to do everything in Python again. But it also comes with a few building blocks to make it easy for the front end to declare, if I hit this button, then I need the new HTML to render here. Like that logic, that is also something that HTML can now handle thanks to HTMX, and I kind of want to give the quickest demo of that just to get sort of the understanding going here. So let's just dive in. Hopefully this is clear, by the way. If there's questions, do send them. I do keep an eye on the chat, and if there's anything that's not clear, I'll gladly do a deep dive. What I got over here is a fairly simple HTML page. It's got the basics. It's got like a head. It's got a body, and there's stuff in it. For our purposes, the main thing that's of interest is that I have a little script over here. This script is technically JavaScript, but the whole point of loading this is that this is going to give us some extra logic that we can use in our web app. In particular, what it's going to allow us to do is that it's going to allow us to add these HTML tags to HTML elements. So I've got a button over here, and that button has an HX post that is attached, as well as an HX target, as well as an HX swap, by the way. That's also something that's declared here. And these are all items that have been declared by this HTMX that we've loaded. Where if you forget to load this bit, you cannot use any of that stuff. But let's read this. This is a button element, and it seems to read post, then go to the increment endpoint. So whenever this button is pressed, that's how you can read this, there's a trigger, and that event is going to tell this website to go ahead and make a post request at this particular endpoint. Then the backend is receiving that request, it's going to handle it, and it's going to send HTML back. But where do you put the HTML? That is defined in this HX-target over here. And you can notice that it has a bang and then counter in the name. That's basically a reference to an HTML element with the ID of counter, which is defined over here. So the thinking again is I hit the button, go to the backend returns HTML, and then I'm going to find this counter tag, which is over here in this span, and then I'm going to swap the HTML that's inside of that span with whatever the backend gives me back. That's the thinking, that's the idea here. And I think what I want to do now is just show this in action, and then I can sort of make some more drawings to make it clear what is happening here. So this HTMX page is being rendered by this app.py file that I've got over here. And what I'm just going to go ahead and do is I'm going to say Python. Let's just run that one file. This is going to start the Flask server. And what I think I should be able to do, because this is a relatively small app, I should be able to open up a browser. Simple browser, show, there we go. And we can just copy and paste this. Oh, let's type it again. Command Shift, that's a shortcut, simple browser show, and there is the URL. And let's go. Okay, so that's a simple browser. Let's put that to the side, just for good measure. So again, you should be able to recognize that some of the stuff we've got over here is what we've got over here. So there's a button with increment in it, and there's a current count that's being shown. And now I'm going to click it. And lo and behold, we can, by the way, we can confirm in the terminal output here that we are indeed sending a post request to /increment. But you can also see that as I increment, the number just kind of updates. And the way that that works, it's relatively basic, is there's just this global variable inside of Flask that's called counter. Every time you call increment, the counter goes up by a number. And then I return the string, and that's what's actually going back to the front end over here. So what we're actually seeing is we are experiencing that we are indeed dealing with a front end. And whenever we click that button, it is going to send a post request to that increment endpoint that's in the back end. I'm just going to call that back. So that's going to the increment URL. And this is basically sending HTML back. My writing's not the best today. But we should write clearly. It's giving me HTML back, and that's and that button element also was telling me to go put the HTML at the right place, and that's basically the circle. Something happens in the front end, we tell the back end that something needs to happen, we get HTML back. Repeat, repeat, repeat. And by doing it this way, and that's kind of the crucial thing, you don't have to worry about JavaScript directly. You still can use JavaScript if you want, and in some cases that's actually very, very sensible. But the main thing is that you don't necessarily have to worry about it. And if you are a Python person, that means that you have one less language to worry about. And also the whole node toolchain is something you can just kind of omit, which is also just kind of nice. If there are any questions about this at this point in time, this would be an excellent moment to ask me anything. I will be moving forward because I like to think that this is a relatively straightforward demo, but if there's anything unclear, I'll gladly hear it. What I'm also going to go ahead and do is just make my face a little bit smaller, because then we have some more screen real estate. So people should be able to see the stuff that I've got on screen. My face is not the main course of this live stream. There we go. Someone is commenting on the cool keyboard setup. Thanks. There are ergonomic benefits to doing it this way, but yeah, it seems like there's not really questions coming in, so that's fine. But what I will be doing then is moving more towards this thing called FastHTML. Because what I've just been doing is using a Flask app, and if you wanted to do this properly, you would probably do something with like Jinja, right? You might make a Jinja template to render the HTML the front end needs to see, and all that stuff is well and good. That's totally a way you could go about it. But another thing you could also do is you could say, well, instead of having this be a Flask app that relies on Jinja, what if we could just maybe really double down on the Python scripting aspect of it? What if we just have this FastHTML app, and that's like an app object, very similar to what we've got inside of Flask. But what we're going to do is, instead of having a template that's a string that we're going to fill values in, how about we just do everything with Python? So we have an h1 tag, we have a paragraph tag, we have a button over here that we are going to generate. And if I put those two things side by side, let's put that next to it. Like, maybe zoom out one smidge. Like if I put these two things kind of side by side, right? If I have a look at this app get, and if I compare that to this HTMX that we've got over here, there's this body in the middle. There's an h1 over here. Well, there's also an h1 over here. There is a paragraph tag over here. Well, there's also a paragraph tag over here. It doesn't, and This one has a span on the inside of it, but it's roughly the same. Like the whole point here is that for every HTML tag that you might expect, we basically have a Python object in the middle. And if you're a Python person, again, this might just be a little bit more easy to reason about. And the way that you pass these things like hxPost is basically by just having that as a keyword argument on the thing that you're interested in. So if you want to call the increment backend, here you would have hx_post because this is a Python object, so we need underscores. But it's really the equivalent of what we've got over here in HTML land. It's just hx- instead. So if you're already well versed in HTML and or HTMX, it is a very natural transition to sort of write your code this way. The interesting thing here, though, is that we don't just have this sort of domain-specific language to generate HTML, we also have an app that comes with it. So where before, if I wanted to build a web app, I could put a most normal Flask projects would require you to have like one file that has your Python code and this other file that has all of your templates. And again, it's actually not an unlikable way of working. But I do want to maybe observe that there's also merits to have everything in a single file. If something is broken, oh, it's just one file I got to check. Not like a JavaScript file there, a CSS file there, or like a template file there. You can, if you want to do something simple, really just keep everything in a single file. And that's actually kind of, I do want to maybe mention that explicitly, because that feeling is definitely kind of nice. To make a to-do app or like a simple increment app, you might only need a multiple of 10 lines of code in order to get that running. And that's kind of a nice vibe. So just to confirm that this does indeed work. So Python, we're gonna now run this this counter example that's fully written in I keep on saying HTMX, FastHTML. If I were now to refresh this, I should go to port 5001. There we go. So, the text is all just a little bit different, but I can hit increment over here. We can see that the print statement that I've got over here is also printing down below here. Again, we're dealing with a global variable, and that is getting a number increase every time I hit increment over here. But this is the gist of it. This is the idea behind FastHTML. This is like the bread and butter of stuff you might do. You're gonna think about what HTML elements you want to add to the entire setup. And once you're there, then you're gonna mainly worry about the Python code you need to render the HTML that you want. And you can reuse these Python objects all the way until you're done. A fun little thing also is note that I'm using from FastHTML common import star. So this is importing a whole bunch of stuff. In particular, you're going to get all these HTML elements, but you're also going to be able to have this main app. And you're also going to have access to this serve function. This serve function is the thing that actually will cause the server to run, like the thing I have down below here. If I were to remove this one line, I wouldn't, like, the script would run and would just end. You do need to add this, maybe in a if name is main, that's something you could do, but this will basically give you this server over here. And one thing you kind of get for free here that's also just kind of nice, I'm just going to make a small edit to the file by introducing a new line. If I were to save this, you are also noticing that we are dealing with a watch file. So this serve command is also checking if a Python file is being updated. And if it is, the server will also restart. So the count is also reset over here. You can turn it off, like there's settings for it, but it is nice that the developer experience is sort of also there. Like you don't have to manually shut down the server or anything like that. That stuff is just all kind of taken care of. So, hopefully we can kind of all agree that this is kind of cool. We're dealing with Python objects, and there's stuff to like about that. But the next, I think, interesting question is, like, what can you build with it? And the first demo that I'll give is focused a little bit more on the data science profession side of things. So I'm not going to be thinking about building the next Airbnb or anything like that. I'm not thinking about making the most scalable web application. The main thing that I'm thinking about is like, hey, I am a person at a company, and sometimes it helps if my demo is not a static Jupyter notebook, but a very interactive web app that I'm just very easily able to sort of mash together. So that's definitely all well and good, but so far, if you look at some of the tools that are like available for this, one of the main candidates that comes to mind is something called Streamlit. And Streamlit allows you to make apps that kind of look like this. Usually, there's like lots of UI on the sidebar over here, and then there are all these widgets that you can interact with. And typically, all of this is generated by Python. And I will say, like, I have gotten a lot of mileage out of this tool. It's definitely not necessarily a bad tool. You get your charts and you have your UI elements, and I think if we have a look at the source code actually looks pretty readable. So we'll just have a quick look at how this would work. Is there a UI thing over here? I think I have to look at app, probably, then dashboard. There you go. It's a lot of context managers basically, but you've got stuff like, okay, in the sidebar, we have an expander, and there are all these UI elements that you can kind of call. There's like a title that you can call as well. And in the end, what it will be able to give you is a Streamlit app that kind of looks like this. But the thing that has always been a little bit awkward with Streamlit apps, at least to me, is that at some point you have something that's functional and you can use their React components and it does all work. But the moment you want to do something kind of custom and you know how to build that in HTML yourself, getting that to work inside of Streamlit has always been kind of awkward. It does work eventually, but you might need to rely on their React toolchain. And again, there's cool stuff to like about Streamlit, but I have always been kind of looking for a tool that can allow me to do the Streamlit stuff pretty quickly, but also then build on top of it using my own knowledge of HTML and web apps. And I think this is kind of the area where FastHTML kind of shines already, even though it's only been out for like a week. So what I want to do is just give a quick demo on how you can build something that really gives you the Streamlit vibe, like UI on the side over here, and then a bunch of UI that renders when you change something over here. Just to show you how relatively easy it is to actually just go ahead and do that. It's honestly like not the hardest thing. So what I think I might do first is just show you what the final app looks like, and then we can dive into a little bit more depth here. I think that's going to be fun. So I'm just gonna cancel this, and let's open up the slider demo that I've got over here. That is now going to run. Takes a bit to start up. Copy that. And then we can switch screens, and we can... Shortcuts are the bane of my existence, but we're getting there. And I think it's gotta be 5001, 5001, not foobar, 5001. What? There we go. Okay, and I will zoom out initially. Yeah, I think this is okay zoom. I think we can kind of deal with this. All right, so what we've got over here is a web app where, just like in Streamlit, on the left side over here, we are dealing with sort of what I will call the UI bits and bobs. So there's all sorts of UI things over here that we can update, and then stuff on the right here will sort of follow suit. And there's actually a couple of UI elements here. Like it's not just text inputs and stuff. There's a slider over here that allows me to increase the noise of the data set that I'm dealing with. So that's all kind of nice and responsive. Then you can also, like we're dealing with a machine learning model here, like a boosted ensemble. So I can increase the number of estimators. And then the finer point of this web app is that you can see that we have a train performance and a test performance. And to get a bit of a feeling for that, I figured I'd add two sliders. Like if I start with very few estimators, then a boosted tree has a lot of trouble actually fitting the data. But then as I increase and increase and increase, it should be able to fit the data more, and more. But then there's of course a concern. Like if I add more noise to the data set as well, and you do notice it gets a bit slower because it has to retrain and all that. But the moment I start adding more noise to this data set, then even though the train performance might still be kind of okay, you will also see that it's showing behavior over here of sort of overfitting. And if you want to combat that, one thing you can do is maybe decrease the number of estimators. Yeah, there you kind of go. And kind of the magic here from like an educational point and perspective is it's relatively easy to make an interface that kind of looks like this. But at the same time, it is also pretty empowering to have someone actually play with sliders to get an intuition of what is happening. And I always kind of like these ML demos where you're not just staring at a static image, you're really invited to sort of play around. And so again, if I were to reduce the noise to its bare minimum, you can see that the number of estimators that we've got over here, it's kind of like underfitting. So we might be able to increase that a bit more like so. But then if we increase the noise again, like it always remains a bit of a balance. And like you're being confronted with that phenomenon as you're interacting with a proper UI here. Anyway, that's kind of the story, kind of the idea behind this web app. So we have some UI stuff over here. And then on this side, we also have a matplotlib chart that can update whenever we make a change here. There's also this other element that allows me to select the model. So before I was using a boosted ensemble, and now I'm using a random forest. You can see that the behavior gets really interesting as I increase the noise. It gets really spiky relatively quickly. And the funny thing with the random forest is even if I add more trees, it doesn't necessarily become more flat. Like you really got to keep the number of trees quite low. And to be honest, if there's noise, it's already kind of impossible for the random forest not to overfit. And there's all sorts of reasons why, and that's kind of the cool thing about this app. Like, why would that be? And as a student, you're kind of being confronted with that, and I think that's also kind of like a nice little demo. To me, this is also kind of feel free to check the theory. There's reasons why boosted ensembles do a bit better, assuming that you're not giving it too little estimators and stuff. But okay, I kind of like this UI, but in a moment I will talk about how I built this using FastHTML, but I see some questions come in, so I will answer those things first. So people are saying that at first glance, the UI seems simpler than Streamlit. I might agree, although I should say the Streamlit app that I just showed you is a relatively complex one. Not entirely fair to compare the Profit thing I just showed you with this, because the Profit thing inherently has like way more settings that you can pick from, and that also makes it more complex. But I will say if you're already familiar with HTML, then I can imagine that you might look at this fast HTML stuff and actually, simply because you recognize so much of it, find it pretty simple as well. Like there's not an API you're learning. If you're learning fast HTML, you're actually learning a web technology at the same time. The real cool thing about that is even if at some point you decide not to use fast HTML for your project because your team wants to use Flask, one thing I can claim is that if you were to invest in fast HTML and you're new to web, you are going to learn quite a bit about HTML and just web stuff in general that will easily translate into other tools. Simply because like the relationship from HTML elements to Python object is so direct. It's a pretty easy sort of thing to learn and also apply elsewhere. It's a pretty general thing you're learning here. And someone is asking, like, does fast HTML perform better on large scale data? Like a lot, I think if you're dealing with like big data sets, both the fast HTML stuff and the Streamlit stuff, it really depends on how you set up the backend. Like, are you doing clever things with caching? Are you doing clever things with the right data frame library and data structures? Like those things tend to typically matter a bit more than what front-end framework you're using exactly. The one thing I might say though, because people are sometimes a little bit confused by it, is, so again, like if this is the front end and this is like the back end, like, you send the request and you get something back. And then some people might come with the argument that, hey, the JSON that I'm sending over the wire here, typically the JSON might be a fair bit smaller than the big HTML blob that you're sending over the wire. So people might say something like, oh, then JSON might be more performant than HTML. I kind of get where that argument comes from, but at the same time, if I think about the time it takes to render over here, like this JSON has to be picked up by JavaScript and being rendered. And instead, if you just fetch HTML from the backend and give that to the browser, like browsers are really good at rendering HTML. So I would honestly not be that surprised, unless you're doing crazy things with the HTML over here. If the front end can just show you the full web app a bit quicker if you just don't resort to JSON and just do everything with HTML instead. I've used it on a bunch of projects, this whole HTMX thing, and I will say it's just really nice. The only sort of downside that I do think might be fair to mention is if you think about like all the stuff you might want to build, like HTMX is great for about 80 to like 90% of all the use cases. There is some stuff that I do build occasionally that is so reliant on heavy interactivity on the front end that that's just not going to be something you do with HTMX, because HTMX really wants to communicate to the back end and then render something new again. So just to give like a somewhat recent example of that, draw data is a thing that I've made a while ago. And there should be a GIF that renders. So this is a thing that you can do inside of a Jupyter notebook. There's a video on behalf of my employer. Like my employer was definitely eager for me to work on this for a bit. But you can see that I'm drawing a data set over here that you can then use inside of a Jupyter notebook. I mean, one difference here is that I am indeed doing this in a Jupyter notebook. So like that's already a bit different. But also just drawing all these data points, you're not going to send a request to the backend for every single data point that you draw. Like there are still these edge cases, especially if you do interactive data stuff, where some of this you might want to have on the front end, right? But those are sort of, if you're doing web apps, this is pretty out there. This is like not a standard thing you might do. So I think in general, I think my gut feeling is about 80 to 90% of UI, you can really get a long way with HTMX. Even though it doesn't necessarily do everything, you can still do a little bit of JavaScript in your HTMX if you want to. So it's kind of an 80-20 rule. It really does feel like with 20% of the effort, you can get 80% of the way, especially if you're doing proof of concepts. Like I maintain a bunch of web apps that use HTMX, and I've really enjoyed using it. But let's now talk a little bit more about HTML, so FastHTML in particular. So what I have mentioned here is that there's this bit over here that's basically kind of like an input field, and then there's kind of this output field, if you will. And the whole idea with this input field is if any of these things change, then I want this whole thing to update. And if you're well versed in HTML, there's actually a little trick that you can do here, which I feel like showing off. So I will close down the simple browser just for now. And this can also go away so we can have a little bit more attention of this slider web app that I just showed you. Let's just zoom in once. And I'm going to talk about this like main page first. So you can see that, there's a title, matplotlib demo. Let's make my cursor a bit smaller there. So there's this matplotlib demo over here. There's an H1 slider playground. There's a paragraph tag. And then there's a whole bunch of other stuff. But just to emphasize that it's not that scary, we see slider playground here. We see a little bit of text. So hopefully that all rings a bell. What's interesting, though, is a few things. So you can see that I've got this main tag over here. And this main tag has a couple of these classes that are attached. So there's a class called grid, a class called grid columns 4, and a class called M8. These are Tailwind CSS classes, and that's a personal preference. I really like to use Tailwind. You don't have to. But what this allows me to say is, hey, there's basically this main entry point, and that has to render as a grid with 4 columns. And I have one div that I declared over here. There's another div that I've declared over there. The first div that I've got has a class of column span 1. So I'm just going to put a 1 here. And the other one has a class of col span 3. Basically, this is a very simple way to declare that I just want to have one row, and that one sort of column has a width of 1, and the other one is just 3 times as wide. That's just the way I can kind of declare that sort of nicely. And that's also what you see if I were to go here. I can inspect the HTML. It might actually be a fun little exercise as well. Let's zoom in on this a bit. But you can see that there's this main entry point over here, and there's this col span of 1 and this col span of 3, and that's how this works. So just like we saw before with the hx underscore trigger, a class is also like a keyword argument that you can pass to an HTML element. The one thing that's a bit of an awkward thing in Python is that class is already kind of taken. So class is spelled with a K inside of FastHTML. But really, I'm just rendering a div. I'm adding like CSS classes and stuff. Note at the top over here, I have my fast app declaration, and I'm telling it to load up CSS files on my behalf. That's also something you can declare up front. But for now, I hope that we kind of understand the layout. That's the first thing I've done. So I've got this main tag over here. That's a grid. And then inside of that are 2 columns, and they have a width. And boom, your layout, you're done. Then there's this one, the thick column that is using a function called show charts. And I'm going to show that in a bit. But before going there, I kind of just want to show a trick that I'm using in the input over here. So this is the part that's really containing all of the inputs that I'm interested in. Notice that that is a form, and forms in HTML are kind of special. The whole idea with a form, usually if you think about a website, is you have like the username, and then you've got like the password, maybe some other information. And then quite typically, there's like a select button, or like a submit button, I should say. And in one go, the form is able to say, these are all the things that have been filled in. Let's send all of that to the backend in one swoop. And that aspect of it is something we can totally go ahead and use again. So this form over here, it has a few inputs. So you can have an input of type range, and you have an input of type range that is basically it turns it into a slider. But there's also this thing as an HTML select element that I can just go ahead and add. And there I can add some options, and I can also attach a name to that. And basically when, because I have everything in a form over here, I can also attach my trigger and my post and my target on that form. And by doing this, I only have to define the trigger once. Like I don't have to add a trigger to every input element that I've got over here. I can just put everything on that one single form and just kind of be done with it. Maybe as a quick fun little demo, let's actually have a look at the log. So the way that the form works is whenever there's an input change, we're going to trigger, and we're going to post to this slider update endpoint. And we can see over here, slider update endpoint. And if I were now to just quickly go back and actually, make a change, like we're going to move this stuff around a bit, increase the number of estimators, maybe set that to a random forest. Because I'm printing, you can also see the data that we get back in. So this slider update over here is receiving some data. And yeah, we have noise, we have estimators, and we have model. And those names correspond with the names that I've basically declared on the inputs over here. So I've got noise, I've got estimators, and I've got model. Just for fun, one thing I could also just do is I could just declare a new input. Oh, not too fast there. So the input over here, let's just have that be type equals email, I think might be legal. We don't have to declare the form over here, I think, but yeah, let's just see what this does. If I were to refresh this now, there is now also a text element in here. So I could do something like Vincent at Vincent Vincent.com. All right, and because I was typing, lots of stuff got triggered. But if I were now to sort of go back and to down below here, like because it's on the form is still sending all the information to this one endpoint. And we can also see that endpoint is printing everything. So we can also see that there's an email, Vincent@Vincent.com is right there. So as a general pattern, what I think is just very nice about it, if you're interested in doing the Streamlit thing, make a small navigation, one column on the left, big column on the right, put your form here, and you're kind of done. Like as far as, oh, I want something to immediately update, this is kind of already where you're gonna want to be at. There are some clever things that Streamlit does do, which I do want to give a shout out to, which is like clever caching, like only trigger the form if, and you can add logic to it. But just the bare bones basics of it, it is just a form inside of FastHTML, which is kind of a nice way to think about it. So anyway, I'm going to remove this part of the form, and then I'm going to move on to how this plot is being generated, because I think that that's pretty interesting too. So let me just first remove this bit, because we're not going to need that. But the next thing I kind of want to mention is like, how do we actually generate the matplotlib chart? Like, how does that work? So I have this function over here called show charts, and that's a function I'm also calling inside of here, right? So I've got a slider update, and there's a show charts function, and this is basically the one function that's going to return me something fast HTML like that actually does contain the image that I'm interested in. Now, to explain how that works, I kind of want to first show you a small website. Because I remember writing about this like years ago. Yeah, on HTML. Inside of HTML, there is this one trick that you can do. So if you want to render a image, right, you can have an image tag, and you can have that point to a URL. In this case, the browser will then make a request, fetch the image, and that gets rendered. That's totally legit. That totally works. But HTML also allows you to have a source that's represented as a base64 image. So you could, if you wanted to, generate this super long string, and then that super long string gets injected into the page, and then you don't need to make this second request. And here you see two images on one of my blogs where this image is being hosted by referring to this route, and this image is being hosted by just having this big URL string that's so this big, basically base64 string. And I have a little bit of code over here that shows you how to do it. What you can just go ahead and do is you can call the base64 submodule of Python, and that can handle all this good stuff for you. But it's this trick that I'm using under the hood to generate the matplotlib chart. I'm not generating an image, saving that, and then having the front end point to that image. Like, that would be wasteful. Instead, what I'm doing is on the fly, I'm generating this string. And with that bit of context, I hope that the following function is going to make a bit more sense. So I have a function over here called show charts. It is using a global data set that you need. Inside of this, I'm doing the scikit-learn stuff. I am making a train and test set such that we can plot the line. I'm doing all that good stuff. But then I am calling matplotlib over here. And I'm doing a subplot trick, and this is all matplotlib, basically. And then at the end over here, I'm calling matplotlib save figure. I am giving that like these IO bytes, basically. That's like kind of like a buffer. Like I'm going to tell it, don't save into an actual file. Save it into that sort of IO bytes object instead. Then I'm going to tell my base64 library to encode what's been saved in here as base64. And then I return, once I've got that encoding, then I return that as an image. And then basically what we saw before is that the string is being placed in there, the base64 string. And because this image then doesn't necessarily need an image that is on like an actual URL path, we can actually just show the user the matplotlib chart on the fly. Now, one thing I do I'm going to toot my own horn here just a little bit. So this trick totally works. It's just that there's a few things under the hood you got to know about HTML if you want this to work. And I cannot blame you if you've never seen this before. So what I have done is I've actually made a little plugin for FastHTML. Let's uncomment this guy. But you can pip install this fh-matplotlib plugin. And what that'll do is it'll give you a decorator that you can put around any function that does plt plot, basically anything matplotlib. And by doing that, you don't have to worry about any of this. This decorator has now been added, and if I were to just go back here, back to that web app, that we can see that everything kind of works as expected. This plugin also does a few extra things under the hood, because if you're dealing with a web app that generates many matplotlib images, you also want to be sure that you don't leak into memory and all that. So that's also something that this, like we close the plots on your behalf as well. But what's hopefully cool by now is that you can kind of appreciate that, oh wait, it's pretty easy to have plugins in this ecosystem as well. So it's cool to be able to show a chart pretty easily. But pretty soon, I think we're going to get a little community here that's going to have a lot of these plugins, such that you can use your favorite notebook tools or your favorite front-end tools. And there was like a fasthtml.gallery. There you go. I think this was the URL. Yeah, there is this website called fasthtml.gallery. Within a week of fasthtml existing, this website also came into be. But here you can just see a lot of widgets and also applications and examples and plugins of stuff that might appear in this ecosystem. So if what I've just told you sounds super interesting, definitely check this out. Because I do think there's a bunch of fun that could be had here. And I'm also looking forward to having more of these like algorithm explainer demos that you can really easily write like at a whim because it's fun. So, okay, that was a bit of a long, stretchy, almost ranty thing from me. Hopefully this was pretty interesting. But I can see that there's a couple of questions, so I will answer them. Someone is asking me, like, have I used Gradio before? I mean, I did the Hello World thing with Gradio, and it's fine. Like, it seems to also make it easier to build, like, interactive stuff, especially from the notebook. But the feeling I have of Gradio is, again, that it is kind of a walled ecosystem. It is kind of a, oh, here's the components you can go ahead and use. And if you want to quickly do the HTMX thing to build your own component around it, that's actually a little bit hard. So I can appreciate Gradio. I do think it has a pretty solid use case, and a lot of people do like it. But I always kind of prefer to build my own HTMX thing. And that's also why I was attracted to this FastHTML. There's another question. How would you approach doing something like draw data in FastHTML? Is it easy to include some front-end JS for interactivity? And yeah, actually, this gallery has a nice example. So this is another plugin that I made for Altair. So Altair is a very likable library inside of Python that can generate these Vega light charts for you. The way that this works, let's just zoom in a bit. So technically, in order to get this to work, you have to inject some JavaScript. And that JavaScript is included in the, this is the plugin. There is a Altair to FastHTML function, and there are these headers that you got to add. These headers are basically references to JavaScript files that you need in order to render this, basically. So by calling FastApp with those headers, I'm including all the JavaScript that's needed to render this Altair chart. It might also be fun to have a quick look at, do I have that in this browser? FH Altair, there we go. So this is the GitHub repository with the code, just to give like the quickest show how I've built it. Like it's a really, really simple plugin. I mean, if you look at the number of lines of code, I think 16 lines of code for a plugin is about as short as I've ever gotten. But the way it works, in terms of like how can you add JavaScript to it, I have these headers, so you can refer to scripts. That's something you can do. But then if I have a look over here, there's also a script here where I'm not referring to a source, but I do have this string that contains a JavaScript function. So if you want to include JavaScript inside of that FastHTML taggy stuff, this is how you would do it. You can open up a file and put the text in here, but you can really just add a string inside of a script tag, and that is going to be resembling JavaScript that you will run in the front end, kind of just like you would normally. And I'm doing something with an f string over here to make sure that everything works. But really, the whole thing that this plugin does is it makes sure that you've got your headers and that I'm setting some sensible settings. That's something I'm mainly doing in this plugin, and I'm making sure that the ID that we're writing to is unique. And some things you don't necessarily want to think about, but the way that I'm able to do that is I'm able to inject some JavaScript as a string over here. That's the way this works. So that also means that if you have custom widgets and custom elements that you're interested in using, you can totally do that, and nothing will stop you. You can kind of come up with a web component of sorts that you just call from Python that has all the JavaScript you need in order to do the interactive thing. Like I might actually, it'll be so much work, but I will consider thinking about adding like the draw data widget that can send custom events just for FastHTML. Like that's something I could consider building. It's just going to be a whole bunch of work because right now it's a Jupyter widget. But yeah, hopefully this is also like a pretty somewhat inspiring example of what you can do. Cool. So hopefully this was useful. I'm going to have a quick look at the time. Still a bunch of people watching. Okay, so we've got like a few more minutes. That's good. Because the final thing I kind of wanted to show, and this is such a geeky, nerdy thing, but like, okay, my employer told me, Vincent, cool, you have some time, try to make like cool demos for FastHTML. And, I honestly think the Streamlit thing I just showed you, that's the main use case you should probably think of right now. However, I couldn't help myself, and I also made a small video game. One that I can actually share with everyone here now. So if you want to sort of play along with it, we're just going to play like one round, and then I'll show you roughly how it works. But the name of the game is Nerd-Snipe Castle. The way it works, you got to imagine it's kind of like a video gamey thing where, okay, we've got a bunch of castles. And let's refresh the page because it's just a little bit easier. So there's a bunch of castles. One castle is worth 1 point. The other castle is worth 2 points. And this happens all the way up until castle number 10 that is worth 10 points. You have 100 armies to allocate, but your opponent does as well. And you could put 10 armies in like castle 1 and 10 armies in castle 2. But let's say that your opponent has 11 armies on castle 2 and you only have 10. Then that opponent gets these 2 points. That's the name of the game. So the question is, can you come up with some sort of a allocation of the armies such that you can beat your opponent? It's kind of like a more mathematical rock, paper, scissors kind of a thing. And I'm going to give like the quickest demo. So one tactic that I'm about to do is I'm going to say, well, I really want to get this castle. I really want to get that castle. So I'm just going to not put anything in there and not put anything in there. And I'm really just going to put many armies onto castle 10, right? So I'm going to hit submit. Oh, and unfortunately, I have a computer opponent that's going to battle against me, but my opponent was a bit more clever, it seems. So it seems that my opponent actually put 51 armies onto this big guy. And because I put all of my eggs into this one basket, I was able to win a few things over here, but these other heavy hitters, I was not able to capture them. So my opponent did. So, okay, I'm going to try a different tactic. How about I put everything in there? I put nothing in that one. And instead, I'm going to add, 25 there, 25 there, 25 there. I'm going to hit submit because I think I've over allocated. So I'm going to be subtracting 5 armies from here. There we go. So submit. And this time I won. Nice. So there's a few things that I let go of, but you can see that even though I didn't win everything over here, but now my opponent has put all their eggs into this basket again. So great. Like I seem to be winning. That's cool. Now, the way that this game also kind of works is you can submit 10 in a row. You're going to be able to submit this a bunch of times. And then you're going to see that your opponent is able to learn from you again. So, it's actually kind of a tricky game because you're always playing rock, paper, scissors against each other. But what I thought would be kind of cool is once you've done one round, you can hit this button called "Got What It Takes to Compete," and what you can then do is you can play against every single human that's also playing this game. So I can hit submit. You get this unique user hash. This is you, and there's also a couple of bots in here. The bots are pretty easy, but the whole point is that you can try to come up with an allocation over here that might be just a little bit better, and everyone on the planet can sort of try to do this at the same time. And the win ratio, that is basically your score. That is the way this is going to work. You get this random hash because FastHTML is able to give you a session. So what I do is you come to the site, and if you don't have a session yet, I'm just going to give you one. And this is just a very unique string, and that's going to be your identifier going forward. Only you know what string you have, so you can kind of keep your identity a secret as you're playing this game. But this is kind of a fun rock, paper, scissors thing that I was also able to like whip out in the day using FastHTML, because it's not just the fact you have these HTML elements, it's not just the fact you can do HTMX, it also really tries to be a somewhat general web framework, so things like sessions are also in there. So what I hope is that people will sort of give this a quick spin. I do think, like, do the math as well, like the game theory behind this is pretty interesting too. But just to sort of give you a quick impression of how this sort of works. Again, there's a bunch of boilerplate here. Like, I'm generating images, and I have these paragraph tags, and I have all of these inputs, and I'm eventually also generating a form just like I did before. And I've got, functions that can generate the big table. I've got all of that sort of stuff. But the main thing that is interesting that I'm doing on top of this is I have my my main route over here. Like, when you get to the website, this is the place you're gonna hit first. And what I'm doing at the bottom here is I'm checking the cookie. So there's a request object that I can pass along as well. So this route, you can see it gets the request. That request object, it has cookies, and I can ask it, hey, from the cookies, can I please get your user ID? And if it is none, then I'm going to give you a redirect response back. So I'm going to tell the browser, hey, redirect the user back to this URL. But before you do that, set the cookie. So I'm going to set a user ID on the cookie. And then when the user gets back, then this request will actually have a user cookie attached. And, it's not a proper login system, but you can see how some of that stuff might be built on this. But what you mainly can see here is that this allows me to sort of, you just come to the site once, and then I have a unique identifier for you. And that allows me to also come up with kind of a leaderboard where the moment that you submit what you think is a great allocation of the armies and sort of the castle and all that, and that is something that you can, then you can have a leaderboard, and you can get that done within a day just by hacking around, and it's just a whole lot of fun, basically. So yeah, I don't know if people are actually playing this. Let me just, whoops. Save it, don't break it. And if I were to sort of resubmit this again, then okay, it does seem that at least one other person is playing, and that one other person isn't necessarily doing. Oh, I beat everyone, but I see that one person needs to have a slightly better allocation. But yeah, like, this is kind of a fun thing. I'll leave this on for like, the weekend or something like that. It is all done in memory, by the way. I'm not using a database here, but I will comfortably say that being able to build stuff like this, that is something I will not see Streamlit or Gradio do anytime soon. Like, this is, sometimes you do want to have something that's just a little bit closer to an actual web app, but still have access to all the good stuff that you're a fan of from the Jupyter Notebook. And I do think, no web framework is perfect, but I do think this web framework in particular seems to strike a nice balance. I do find myself to be productive in it, and I also see myself having a bit of fun with it. So yeah, I'm gonna, after the live stream is done, I'm going to, have some show notes under this video, and I'm going to link to this GitHub repository that has all these FastHTML examples that I've made. This is kind of like my personal collection, if you will. And it also has the code for this game. It's pretty easy to set up Railway, to point to the repo and just launch it, which is what I've done. But what I'm moreover hoping is that this is kind of exciting to a lot of data science people. Like, I can't imagine, like, I started doing Python because I started doing Django 10 years ago, and it was definitely kind of a big learning curve because we didn't have Jupyter notebooks back then. But I can imagine that if you're kind of the data science person doing a lot of stuff in your notebook, this is a cool entryway to actually start doing some web appy stuff as well. And usually a data science algorithm needs a UI, right? So like being able to actually quite comfortably build with that, that is also like super useful and cool. A final quick, mega quick demo that I also just want to show. Suppose now that you're not necessarily a data science persona, let's say, but you're more of a Flask person. It could be that you're still interested in using Flask because Flask in the end is a great framework. Well, if you wanted to, you can still use that HTML declaration stuff that FastHTML brings to the table. I wrote another decorator that sort of can wrap around a function to turn this into something that Flask can render. The main thing I got to do is just use the internals of FastHTML to make sure that this is properly a string, and then this is nicely converted to HTML. Like you can also use other web frameworks and then use FastHTML inside of it. That is also something you could go ahead and do. So that also means that if you like the matplotlib stuff and you just want to get that working inside of Flask, you can do that via FastHTML. And that is also an avenue that I think people might want to consider. Because if you don't use the server inside of FastHTML, you can still do stuff like this. And that is just kind of nice too. So as you might have been noticing at this point, is that I am actually relatively excited about this. Before wrapping up, I do want to maybe mention that even though I am a big fan of FastHTML, like I do see myself doing some productive stuff with it, I also want to just mention I still love Django, and I also still love Flask. Especially Django. I think about like all the stuff it does under the hood in terms of security, that's great. And I definitely still want to keep using that from time to time. I just see this as yet another pretty solid choice that you could go for. And the main benefit of this one in particular is that this is relatively beginner friendly. Flask is relatively beginner friendly too. Django is, reasonable, but there's definitely a learning curve, you could still argue. And I also think that, I'm a person who also writes JavaScript from time to time. I don't think that JavaScript is necessarily evil. But I do think that I'm not the biggest fan of the NPM framework. Like having one less build system is a good thing usually. But what I really like about FastHTML is that you can choose whether or not you want to use JavaScript. And that I think is a really cool thing. Like if you don't feel like you want to learn JavaScript, like I can actually recommend it. Having a bit of JavaScript skills is cool. You can definitely use that in cool places. But if you don't want to, you don't have to. And that's also like a very cool thing here, I would say. Okay, I can feel my throat at the moment, which means that I've been talking for a while. We are also at time, so this has been hopefully a productive hour to all of you. I will share all this code, and I hope people will enjoy it. I am going to leave this open for just a few more moments, just to see if people have questions. Because if they do, I'll gladly stick around for another 15 minutes to answer any that you might have. It seems silent, which is totally fine. And I see some hearts go up. All right, so that was it for today. I'm going to make this guy flat now because that feels appropriate too. Thanks for listening, everyone. I guess like a final thing, like last week I was mentioning that I was actually thinking about making a scikit-learn plugin around mixture density networks. FastHTML happened last week, so I figured I would jump on this thing first. I'm probably going to pick up the scikit-learn plugin for the live stream next week, though. There is some other stuff that's been happening that I also want to talk about. But if you are interested, that is definitely cool. Tomorrow, I'm going to release a new whiteboard video. That should also be fun. But yeah, I've been talking for a while. I need a drink. Thanks, everyone, for listening. If there are extra questions, you can always add stuff to the comments. But I am seeing that people are interested in giving it a spin. So great. I'm going to hit end broadcast and have a good lunch. Have a good day.